Welcome to today's Science Inquiry. I'm George Wolf. Now, today's inquiry is going to use some magnets, a compass, and your sense of direction. Now, let's just talk a little bit about these things called magnets. You may know that all magnets have two poles, and in this case, I have bar magnets that are labeled so we can keep track of them. One is labeled N for north, and one is labeled S for south. Now, there's this basic premise you also probably know about magnets, and it's this, that like poles will repel and unlike poles will attract. So if I bring the north one to this south one, they're unlike. Let's see if they attract, and sure enough, they do. And if I bring the like poles together, north to north, theoretically, I should not be able to get those together, and I can get that north to run away from this all day long, which is kind of fun, but has nothing to do. Maybe it has a little bit to do with an inquiry I'm going to ask you to think about. But first, I want you to look over here. I have a compass. And this compass, if you've ever worked with a compass before, you know that every compass has a needle on it, and it's labeled with an N. All right? And that's supposedly going to help you to never get lost because that's pointing toward the north. All right, so we call that the North Pole of the compass, if you will. And now you're going to be ready for a question. But before I ask you the question, I'm going to want you to look up some information and some terms. And the thing I would really look for is information about the magnetic field of the Earth. Okay, magnetic field of the Earth. Now, after you've looked that up, we got a question for you, and here it is. If I bring the North Pole of this magnet close to the North Pole of that compass, what do you predict will happen? Will the North Pole of that compass go toward the North Pole of this magnet or away from it? Seems pretty simple, doesn't it? Good luck. When you answered that question, did you predict that the North Pole of the compass would repel from the North Pole of this magnet? Well, if you did, you're correct. But boy, that's a puzzle. Now let's take a look and see what's going to happen. As I bring this North Pole of the magnet close to the North Pole or to the compass, you see what happens. There's that north. It's look at it, it's kind of moving away. In fact, if I switch this magnet around and bring the south, the north points to that. Now, is that a little discrepant or confusing to you? I thought compasses were supposed to point to the north, not the south. Let's go to the board and figure this one out. Okay, now you know the answer to this puzzle starts with the Earth. You probably know that the Earth has a magnetic field that is probably caused by the iron core spinning in the middle. And we've decided to call the top of the Earth, if you will, the north side, and this one the south side, or the North Pole and the South Pole. And we have this thing called a magnetic field in the Earth. And it follows pretty close lines. Well, we've come up with this thing called a compass. And what a compass does, and now comes the key here, a compass points along these lines. So if I have a magnet and I say it's pointing in that direction, we're not going to call this the North Pole of this compass because guess what? The North Pole of the Earth is up here. We're going to call this the North Seeking Pole. Now it makes sense. We've shortened it to the confusing word north, but it's really the North Seeking Pole. So of course, if I have a bar magnet, well, a bar magnet isn't the Earth. It doesn't have a North Pole. It has a North Seeking Pole. So a compass needle is just a bar magnet. So of course what's going to happen is these two poles are alike. They're going to repel. So it's all what we call semantics. No discrepancy. I hope it makes perfect sense. So let's take a look at what we've learned here in this inquiry. First of all, like poles of a magnet repel. Unlike poles, attract. Third thing, we have named these poles north and south. We could have named them Tom and Mary, but we chose north and south. And here's the last one. The North Pole of the magnet really means north seeking and is really the opposite magnetism of the North Pole of the Earth. Now that's pretty cool stuff. I'm George Wolf, and I want you to remember to discuss today's science inquiry with your class and your teacher. And I'm going to challenge you next time. But remember this, If you don't ask any questions, you're not going to get any answers.